Hey, all you cool cats and kittens, it's Linz from the Pre-Calc team, here to give you your latest video. First off, here is the answers to number 5 from your note sheet from yesterday that Mr. Roth had you guys do. Give you a chance to look through those answers. Pause the video if you need some more time. We are going to continue on with number 6 on the note packet that you got yesterday. Again, if you printed it off yesterday, that's great. You can follow along with it. If you didn't, you can just be taking notes on what we're going to be talking about today. So I am right now talking about... We're going to start here on the bottom of page 2 with vector quantities. So we're going to start with the magnitude of a vector. So our first vector is W. It has a component form of -2, 3. Back onto there. So I've got the vector up here for you. Yeah, I made a whiteboard out of my patio door. Ingenuity at its finest. Okay. So if I were to draw out this vector, we would have -2 would mean I'd go to the left 2, up 3. That's where my head is going to be. The tail is going to be at the origin. So this is -2 there and 3 there. So what that does is that creates for us a right triangle. Now the magnitude of a vector is the vector's length. So if we think about this as a right triangle, I would think about this as the square root of 3 squared plus -2 squared. And I would write that in simplified radical form. So that would be, so the magnitude here of W, magnitude symbol is a double absolute value symbol. That's going to be equal to the square root of, if we think about it in terms of the actual vector given, oops, now I got a butterfly flying around, all good stuff. Tuck him up there, maybe. Good times. Take the square of that one, add it to the square of that one, and then take the square root of that. Pythagorean theorem, if you will. So that's going to be the square root of 4 plus 9, or the magnitude, the length of my vector, is going to be the square root of 13. We leave that in simplified radical form. That gives us exact answers. We like exact better than rounded. Now we need to find the direction angle for that same vector. Or in this case, we're going to call it theta of W. Well, just to confuse you even more, because we just got done with navigation, direction angles are back to trig angles. Okay? So that means then that 0 is over here, 90 is up top, 180 is out to the left, and 270 is back down on the bottom. So we're back into that trig angle working through this. Okay? So if I need to find that angle of that vector, then that is going to be that big angle there. So I need to think again of reference angles. So I would find my theta prime of this little angle right in here. Oops, get my fingers going the right way. Of this angle right there. Then I can subtract that from 180 to get the big angle, the true direction angle of my vector. So if I'm thinking of theta prime here, that's going to be the inverse tangent of y over x, and I'm going to drop any and all negatives. Okay, so that's why it's just inverse tangent of 3 over 2. Punching that in on my calculator, I get 56.3099 degrees as my theta prime. Now, because I'm in quadrant number 2, my actual theta is going to be 180 degrees minus theta prime. So that's going to give me an actual angle, which we'll call theta sub w, for the direction angle of vector w, is going to be 123.69 degrees. With a magnitude of the square root of 13. So now we're on page 3, the top of page 3. So now let's try number 6 here. If u has the vector of 1 comma negative square root of 3, we want to find the magnitude of u and the direction angle of u. So there's my vector. U is 1 comma negative square root of 3. Okay? So in thinking about where it is, positive 1, negative square root of 3 would put me down here, which would be, this side would be 1, this side would be negative square root of 3. Okay, so my angle that I'm going to be looking for is all the way around here, which means then that is my theta prime up in there, using reference angles again. Let's find magnitude first. Oops, I went W, should be U. Big square root of 1 squared plus negative square root of 3 squared. 1 squared is 1. Negative square root of 3 squared is 3. Oops, that's a bad looking 3. 1 plus 3 is 4. So the magnitude of U is the square root of 4, which is 2. Okay? Now we need to find the direction angle. Theta prime is going to equal the inverse tangent of square root of 3, because I dropped the negative sign, all over 1. That's going to be the inverse tangent of the square root of 3. That's on my unit circle. That's going to be 60 degrees. Okay? So my actual theta, because I'm in quadrant number 4, 360 all the way around, but I got to come back 60 degrees. So it's 360 degrees minus my theta prime. So my direction angle, theta sub u, would be 300 degrees. Okay. Seeing if I can get rid of the glare. I don't think I can get rid of the shadowing effect going on because my lamp's down here on the floor trying to get the things that we're doing. Making stuff up as we're going along. Love it. Okay. So now let's move on to number 7. Number 7 says that we have the magnitude of V is 6, so that's the length of our vector. Remember, that's the magnitude is length of the vector. So the magnitude, the length of our vector is 6, and our angle is 135 degrees. Well, if I am thinking about 135 degrees, 0's over here, 90's up here, 180 is over here. So I'm going off at a 45 degree angle in there with a length here of 6. I need to find vector V in component form. Well, if I make my right triangle, I know this angle down here is 45 degrees because this whole angle here was 135 degrees. So that leaves me with 45 in there. That means that I can find my x value by saying the cosine of 45 degrees. Oops, I should rewrite that as x is cosine of 45 degrees is x over 6, or x is equal to 6 cosine of 45 degrees, which is approximately 4.243. Y, then, instead of using cosine, I'm going to use sine. The sine of 45 degrees is now y over 6. So then y here would be equal to 6 times the sine of 45 degrees, which would also approximately be 4.243. So the component form of vector V would be I'd have 4.243 and 4.243 as my horizontal component and my vertical component. However, because I'm in quadrant number 2, that horizontal component has to be negative and the vertical component has to be positive. Okay? In general, any vector, let's call it vector V, okay, is going to be equal to, or the component form of the vector is going to be equal to the magnitude times the cosine of the direction angle, comma, the magnitude times the sine of the direction angle. And that's going to happen for any vector. If we need to put it in component form, you'd know the magnitude, you know the direction angle. We can find the component form of the vector, so we can do head to tail rule. We can, we can scalar multiply the vectors, all that good stuff comes out of this right here. Magnitude cosine, magnitude sine. So your one problem for homework tonight, what I'd like you to do is I would like you to do number 8. You can do number 8 probably within the next 5 minutes. And if you do so, there's a video, or there will be a video posted very much where you found this video, showing you the correct answers and how to do number 8 for after when you've done it yourself. But I want you to try this one on your own and do number 8, much like we were just doing those problems. And that's all I got for you today. Hey, be a warrior today.